Continuing on with writing the slope deflection equation, recall that we have relative stiffness of the members for the columns that are 3/4 of the stiffness of the beam, right? And that the theta A term is 0, that's the fixed end associated with that column, the actual support condition. You've got no applied loads to the member, so the fixed end moment is 0 as well. So the only thing we got is the theta B and the chord rotation term, and now when we substitute in, we've got 2 times E times the 3/4 K, or in other words, we'll have then 1.5 EK theta B, and then again we get the 3/4 going in times the 6, so that'll become 9/2, or 4.5 EK, and we decided that since psi AB equals psi CD, two columns were the same, that we just call that psi as a general thing. Again, no fixed end moments. There you go. Now when we go to the other end of the member, then the coefficient, the only thing that's different is the coefficient on the rotation term is twice as big, so that's 3 EK theta B minus 4.5 EK psi for the left hand column. For the beam, then same story. We're going to substitute in. We've got the beam has rotations at B and C that are unknown. It does not have a chord rotation term, but it does have a fixed end moment. So we get, and here the relative stiffness, the KBC, was equal to what we called K. So we just have direct, bam, 4 EK theta B plus 2 EK theta C, and the fixed end moment term on the left was minus 25. Fixed end moment term on the right was plus 25, and of course the coefficients on the rotation terms flip-flop. Now the other column is essentially identical to the first. At the top end we get the bigger coefficient that goes with that unknown rotation. We have the chord rotation term, and then at the bottom of the column we have the 1.5, and then again the same chord rotation term.